And here we are, lesson 7.3, more multiplication properties of exponents. I really hope that these videos have been helpful and useful, and that you guys are learning how to take advantage of them.
If you haven't... Oh my gosh, I found a new button. My face can be on these videos.
So the first thing we're going to talk about, which is actually something we talked about where in the book, is in 7.2, but we're going to go ahead and talk about it now. It's scientific notation. Scientific notation is just a quick way of writing large numbers or really, really small numbers with lots and lots of zeros as a product of 10. So what we do, you take your decimal place, wherever it is, and you're going to move it. If you're moving it left, your exponents will be positive. If you're moving it right, your exponent will be negative. So here we're moving 1, 2, 3, 4, 5, 6 times. So in scientific notation, our number would be 2.0 times 10 to the 6. Now this next number, we're going to be moving in to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we will have 9.0 times 10 to the 9th. Hopefully scientific notation is review for you. In light of our exponent work that we're doing, let's look and see if we can simplify this equation. Because of the commutative property of multiplication, we can rewrite this as 9 times 3 times 10 to the 7th times 10 to the negative 16. 9 times 3 is 27. And when we have the same base raised to powers, we add those together. So this will be 10, 7 plus negative 16 will be negative 9. Now remember, scientific notation, we want it to be a number that's only in the ones place. So we need to take this and we want to move our decimal place over to be in between that 2 and the 7. So when we move it to the left, remember we are going to add 1. So this will be 10 to the negative 8. Moving on to some more exponent work. When we're raising a power to a power, we're going to multiply our exponents. So this first problem, x to the 5 to the 2, we're going to multiply our exponents and we will get x raised to the 10th power. M to the 3 to the 4, we are going to get m raised to the 3 times 4, which is 12th power.
Are you taking notes? Take better notes. Your notes aren't good enough. More notes. Come on, write them down.
Now, when we have fractions, it doesn't really change anything. We're still going to multiply together our exponents. So in this equation, we still have x, but now we multiply our fractions. Remember, when you multiply fractions, you multiply straight across, so it's now x to the 3 over 7. Now they start to get a little more tricky with a few more steps that you're going to have to do. So we need to remember our order of operations: parentheses, exponents, multiplication and division, and then addition and subtraction. So first we're going to do our exponents this way. When we're raising a power to a power, that comes before doing the multiplication. So our equation now becomes x squared times x to the negative 24th. Now when we have two bases raised to different powers, we're going to add those powers together. So we now have x. 2 plus negative 24 gives us negative 22. And when we have a negative exponent, that brings it to the other side of our fraction line. And this is our simplified form. To raise a product to the power, you want to raise both factors and then multiply. Now, this is sort of like distributing in a way. We are now going to do 3 to the 4th power times x to the 4th power. So 3 to the 4th power means 3 times 3 times 3 times 3. That'll be 9 times 9, or 81. So our simplified expression is 81x to the 4th. Well, class, does it make sense so far? Are there any questions?
Anyone? Anyone? None? No questions. You sure? Then let's move on.
Sometimes we're going to have to work a little harder to break everything down. Here we start with exponents again, remember PEMDAS. We can call this 10 over 1 and we'll multiply straight across. We'll get n to the 10 over 2. Then we want to take this exponent and bring it to each of the things inside the parenthesis. So 4 to the 3rd, m to the 3rd, and n to the negative, we have to multiply our exponents, 6 over 3. Let's try to do a little simplification. 10 divided by 2 is going to be 5. 4 to the 3rd, that'll be 4 times 4 times 4, or 16 times 4. Let's write it out. 16 times 4, that'll be 24. 4 times 1 is 4, plus 2 is 6. So we have 64. M to the 3, that's perfectly fine. N to the negative 6 over 3, which would be negative 2. Let's combine our like terms. Commutative property allows us to move things around. I'm going to have my 64 in the front, m to the 3rd, and then when we're multiplying n to the 5th times n to the negative 2, we add those, and we will get n to the 3.
Knock, knock. Who's there? Interrupting cow. Interrupting cow who? Moo!